All right, let's talk about one of those mistakes in C# that's super common, super easy to make, and can be incredibly costly. It all comes down to a single tiny keyword that can either be your best friend or send you down a rabbit hole for hours chasing a bug that's hiding right under your nose.
No, seriously, I'm not exaggerating. One little keyword can just poof, completely obliterate your stack trace. And you know how crucial that is, right? The stack trace is everything. It's your map, your breadcrumb trail that leads you right to where the code broke. Losing it, that's like a detective showing up to a crime scene and finding out all the evidence has been scrubbed, you've got nothing to go on. Okay, so here's the deal, the absolute core of it. When you're catching and then rethrowing an exception, just using throw, well, that keeps that precious breadcrumb trail intact. But if you use throw X, oh man, that's the destructive one. It completely wipes the slate clean. It starts a brand new trail right from where you caught it and completely hides where the real problem started. I know, that might sound a little abstract. So, you know what? Let's just see it for ourselves. We're going to run a super simple experiment to show you exactly what I mean. So here's our setup. It's a really basic call chain. We've got our main method, which calls method 1. Then method 1 turns around and calls method 2. Now, inside method 2, that's where we're going to cause some trouble. We're intentionally creating an error, a classic divide by zero. So the bug starts in method 2, it'll get caught in method 1, and then we'll rethrow it so it can finally be handled back in main. Simple, right? Okay, first up, let's look at case 1. This is the right way to do it. We're going to catch that exception in method 1 and then rethrow it using just the plain throw keyword. So look inside the catch block for method 1. All we have is that one line, throw. That's it. This basically tells the program, hey, I see there's a problem here. I'm not going to touch it. Just pass it up the chain exactly as it is. And boom, look at that result. This is perfect. This is exactly what we want to see. The stack trace shows the whole story. The error started in method 2, it went through method 1, and it ended up in main. We have the full picture. Debugging this? Super easy. All right, now, let's break things. Time for case 2, the problematic one. Let's see what happens when we make that one tiny change and use throw X instead. So we're going right back into that same catch block in method 1, and the only thing we're changing is adding that little X after throw. It looks so harmless, right? But trust me, this tiny addition is about to change everything. Okay, we run the code again, and here's our new output. Now at first glance, you might think, okay, looks pretty similar. I still see a stack trace. But look closer. Something is definitely off. Seriously, take a second. Compare this to the first output we got. Do you see it? What's missing? What crucial clue just disappeared? Yup, you got it. Method 2 is gone, vanished. The stack trace now starts at method 1. It makes it look like the error happened there, which we know is a total lie. By using throw X, we've basically destroyed the original crime scene and pinned the blame on an innocent method. Can you imagine trying to debug this in a huge, complex application? You'd waste so much time digging in the completely wrong spot. Okay, so understanding this difference is just absolutely critical. To make sure this never, ever trips you up again, let's lock in a simple golden rule. Let's go back to our detective analogy because it's perfect for this. Using throw, that's like getting the full, unedited CCTV footage. You can see exactly what happened, step by step. But using throw X, that's like the detective showing up and finding out the most important part of the tape has been wiped. The trail's gone cold, you've lost your lead. So here it is, the golden rule of rethrowing. If you catch an exception and all you want to do is pass it up the chain, you always use throw. Always. Using throw X in that scenario, it's pretty much always the wrong move. Okay, so right about now, you're probably thinking, well, is there ever a good reason to use throw X? And that's a great question. The answer is yes, but it's very rare and it has to be done in a very specific, intentional way. The only time this pattern is really correct is when you're intentionally wrapping the original exception inside a new, different one. See the syntax here? You're creating a new exception, and you pass the original one, X, as the inner exception. This is a conscious design choice. You might do this, for example, to hide the messy details of a database error and show a cleaner, more user-friendly application error instead. You're hiding the internals,
but you're still keeping that original trace tucked away inside for logging.
All right, let's wrap this all up. Time for your final takeaway. This table really says it all, doesn't it? Let's just run through it. With throw, you keep the trace, debugging is easy, and you see the real origin. With throw X, the trace gets reset. Debugging becomes a nightmare, and the origin is hidden. I mean, when you see it laid out so clearly, the choice is pretty obvious.
And that's really all there is to it. You just learned one of the simplest yet most powerful ways to make your debugging life so much easier. So it kind of leaves you with a question, right? What other tiny little habits in your code have a huge outsized impact on your work? Something to think about. Thanks for joining me on this one.